4.2 Graphs of Basic Functions. This is chapter 2.6 in your book. 4.2 Opener. In this section we'll look at the graphs of some basic functions and get used to their domains. We will later combine these basic functions with trig functions. You should be able to quickly sketch a graph of these basic functions, right? You shouldn't be spending too much time on these. You should be able to quickly state the domains of these functions, and you should be able to quickly graph these functions using a calculator. Graphing basic functions. Definition: a function is continuous if its graph can be drawn without any breaks on its domain. So for example, there's no breaks in the x values. So here's a function that's continuous. Notice it's nice and continuous. There's nothing weird going on. Here's a function that's not continuous. It's nice and smooth, but then there's a break and it starts back up here for some reason. So continuous, not continuous. Not continuous. The identity function. This is the simplest type of function. F of x, which is what we're calling the function, is equal to x. The identity function just means that whatever you put in for x is the same thing that you're going to get out. So if we were to plug in -5 for x, that would have to come out as -5 for x over here. Right. If we were to plug in x squared plus 1 into the identity function here, x squared plus 1, then x squared plus 1 would have to come out here. The squaring function, one step up. The function f of x, where you take x and you're going to square it. So if I were to plug in any value like -5, again, I'm going to take that and square it. -5 squared, which would in this case be -5 times -5, which is 25. Okay. If we look at the graph for the squaring function, right, we can plug in some easy values here for x and see what comes out for y, or what comes out for f of x. X and y. Let's try -2, -1, -1, 0, 1, and 2 for x. So f at -2 is equal to -2 squared. -2 squared is 4. -2 times -2. F of -1 is equal to -1. Notice I'm putting parentheses there. Squared. -1 times -1 is 1. Likewise, f at 0 is equal to 0 squared. 0 times 0 is 0. F at 1 is 1 squared, which is 1. And f at 2 is 2 squared, which is 4. So we have f at -2 is 4, f at -1 is 1, f at 0 is 0, f at 1 is 1, f at 2 is 4. So we're going to graph that here. At -2, we have 4. 1, 2, 3, 4. -1, we have 1. 0, we have 0. 1, we have 1. 2, we have 4. And if you were to graph enough of these values, you would see that this thing curves in a little bit and then curves back out. We call that the parabola. We call that a parabola. Okay. And the vertex is the lowest point. We've already talked a little bit about this. The lowest point, in this case, it would just be 0, 0. The cubing function, this is the function f of x is equal to x cubed. Likewise, you're taking values, -3, -3, notice I'm putting the parentheses there, and cubing it. -3 times -3 times -3 is equal to 3 what here, negative 2 times negative 3 is positive 9, times another negative 3 is equal to negative 27, etc. You could draw your own little, you can do your own little x and y table and plug in some points like negative 2, negative 1, 0, positive 1, and positive 2, and see what values come out. Negative 2 cubed would be negative 8. Negative 1 cubed is negative 1. 0 cubed, 0 times 0 times 0 is 0. 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is 8. So I'm going to graph those right there. They're 0, 1, 2, negative 1, negative 2. Again, at 1 we got 1, at 0 we got 0, at 2 we got 8, at negative 1 we got negative 1, at negative 2 we got negative 8. If you were to draw enough of these points, you would see that the graph looks a little like a snake-like is what we say. But it starts way down low and then it comes back up, smooths in a little bit, then curves back around. By the way, the domain of the parabola, this first example, the domain is from negative infinity to infinity. In other words, all these x values are being used up. All these x values. The range, however, of just x squared, the range of x squared by itself is the y values. Notice that the lowest y value is 0, so it starts at 0, and we include 0. And all the way up to infinity, all these y values are being used up. So 0 to infinity. The domain for the cubing function is all the x values are being used up, notice. So it's negative infinity to infinity. And the range, notice all the y values are being used up. Keep doing that. So the range is negative infinity to infinity. Likewise, the square root function. This is the function f of x is equal to the square root of x. And again, we're going to make a table here, and we're going to plug in easy values for x, values that we can take the square root of here, like 0, like 4. Here, I'm going to put 0 here. 0, 4. We know the square root of 1 too, so let's try that one too. 1, 4. We know the square root of, what, 9? Okay, so f at 0 is equal to the square root of 0, which is 0. F at 1 is equal to the square root of 1, which is 1. F at 4 is equal to the square root of 4, which is, what? 2. So 0, 1, 2, what's the square root of 9? 3. And again, we're going to graph it. Notice that we can't take the square root of any negative numbers here. X has to be bigger than or equal to 0. So the x values start at 0, 0, comma 0, that's a point. Then 1, comma 1, 4, comma 2. So 1, 1, 2, 3, 4, comma 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, comma 3. And this is the square root function. It starts off very steep and it rapidly levels off. This is the graph of the square root of x. What's the domain here? All x values are allowed starting with 0 and on. What about the range? What y values are allowed here? Or what y values come out? Yeah, 0 to infinity. Right here. The cube root function, this is the function f of x is equal to the cube root of x. What types of numbers can we take the cube root of? We can take the cube root of numbers like 0, we can take the cube root of 8, we can take the cube root of negative 8, we can take the cube root of what, 27, negative 27. I'm running out of room here. Let's make another table here. 27, negative 27. Alright. So f at 0 is equal to the cube root of 0. In other words, 0 times 0 times 0 is equal to 0, so 0 is the cube root of 0. F at 8 is equal to the cube root of 8. 2 times 2 times 2 is 8, so the cube root of 8 is 2. What about the cube root of negative 8? Well, negative 2 times negative 2 times negative 2 is negative 8. So negative 2 is the cube root of 8. So there's our y values there. 0, 2, negative 2. The cube root of 27 is 3. 3 times 3 times 3 is 27. The cube root of negative 27 is negative 3. And now we can do the graph here. 0, 0 is where we start. 8, comma 2. 27, comma 3. Negative 8, comma 2. Comma negative 2, sorry. Negative 27, it's way down here, comma negative 3. So notice it looks kind of like x cubed, only kind of like x, the square root of x2, but it's a little bit sideways. Okay. And the domain is all real numbers. All real numbers are allowed because we can take the cube root of any number. And the range is all real numbers because any number is going to come out. The absolute value function. This is a very important function. F of x is equal to the absolute value of x. Remember, what that means is that you're going to take x and make it positive. So if I give you an x like negative 2, negative 1, 0, positive 1, positive 2, all that's going to do is make them positive. So the y's are 2, 1, 0, 1, 2. In other words, on this right side here, 0, 0, comma 0 is 1, 1, comma 1 is another point, 2, comma 2 is another point, there's 2, comma 2, 3, comma 3 is another point, 4, comma 4, etc. On the right side of the graph, we just have a straight line. It's like the graph of f of x. It's like the graph of f of x is equal to x. On the left side, when we have negative 1 for x, we still get positive 1 for y. So negative 1, positive 1. Negative 2, positive 2. Negative 3, positive 3. So it looks like a line on the left side as well. So it's V-shaped is what we say. So that's the graph of f of x is equal to x. Looks like a V. The greatest integer function. This is a new function, and we denote it by brackets. This is the greatest integer function, and all it does is it gives out the greatest integer. Remember, whole number, negative or positive or 0. The greatest integer less than x. So let's look at some examples here. If I were to plug in 1.5, what's the greatest one? The greatest integer that's less than 1.5 it has to be less than 1.5. Like negative 2, 0, 1. They're all less than 1.5, but what's the greatest one? 1. What about 2.7? There's a couple things that are smaller than that. There's lots of things. There's an infinite amount of things. Negative 5 is smaller than that. 0 is smaller than that. 1 is smaller than that. But 2 is the smallest, is the biggest one that's also smallest, at 2.7. Remember, we need integers, just whole numbers, positive or negative. Negative 3.5. What's the smallest? What's some smaller numbers than that? Negative 4, negative 5, etc. Negative 3 is not smaller than negative 3.5. So we need negative 4. Okay. So now we have the idea we can graph this. From there's 1, there's 2, there's 3, there's 4. So all these numbers in between 0 and 1, for all those numbers, the greatest integer less than all of them is just 0. For all the numbers between 1 and 2, like 1.5, The greatest integer less than that is 1. For all these numbers here between 2 and 3, the greatest integer is 2, etc. So it kind of looks like a little step ladder. That's the greatest integer function. Okay, before I let you try these examples on your own, I want to show you how to quickly do them on the calculator if you're not used to working with the calculator. Okay, now we're going to graph the function f of x is equal to x. So make sure you turn on your calculator. We're going to go to y equals, and we're going to clear whatever's in there, and we're going to hit x. Then we're going to hit graph. And there's the graph of f of x is equal to x. It's the identity. For -5, it gives you -5. For +5, it gives you +5. Now we're going to graph x squared. That's the parabola we were talking about earlier. We're going to graph the absolute value of x. For the absolute value, you have to go to the math option here. So hit math, scroll over to number, hit right. Notice the first option is absolute, so we're going to hit enter. And then we're going to type in x. That's the absolute value of x. Close the parentheses, and we're going to graph it. The V shape that we talked about. Okay. X cubed, we're going to take x, and we're going to raise it. We're going to have to use this caret symbol here. Raise it to the, let me go back, to the third power. There's no cube symbol here, so we have to raise it to the third power. Then we graph. There it is. Y equals. We're going to do the square root of x here. Second, we have to hit second here because the square root is using a yellow symbol here. So we're going to have to use second square root and then x, and then close the parentheses and graph. There we go. Y equals. Now notice if you go to math here, there's for different square roots, if you scroll down, there's one that says cube root of x, and there's one that says x root of x. So if you wanted to use this x root of x for different roots, you would have to type in your x first. So let's try that for the cube root. We're going to quit. We're going to go to y equals. Since we want to do the cube root, I'm going to type in 3 first. Then I'm going to go to math, scroll down until I get to that one. Hit enter. So this is technically doing the cube root of x. And then I'm going to graph. Okay. That's it. If you have any questions about the calculator, make sure you ask. There's lots of things that you can do with the calculator. So now pause and try these on your own. Can you quickly sketch the graph of x squared? Remember, that's a parabola. It starts right at 0. If it's just x squared, it starts right at 0. What about x cubed? It's a snake-like pattern, right? What about f of x equal to square root of x? The square root of 0 is 0, so it starts at 0, and then it's really steep and then levels off. Sorry about that little bump right there. F of x is equal to the absolute value of x. It's V-shaped. There we go. You should now be ready for your homework on section 4.2.